Alright, check this out. You have an application that implements background jobs, and let's say it has multiple clients with multiple organizations, etc. A user asks to generate a whole bunch of reports, and as you can see, these jobs are being dispatched, but what happens is one of these jobs fail, and the user is not here to see what is going on, right? They are background jobs, they're being executed in the background, and you might be thinking, yes, but I do have Sentry errors implemented. Well, let's actually see. Here's the error that happens in one of those jobs. It says invalid memory address or nil pointer dereference. Okay, so it happened in the worker/main.go file in the process HR report. Okay, so we know that it is the HR report that is breaking when we try to generate it, but why? We have no idea why. We know that we can process HR reports, but something is breaking, right? Well, let's see if we have anything added. We have the error type set to panic here. We tried to parse the data and add it, but as you can see, it's basically null. So that failed, right? So we don't really get any details because it's a background job. It is being shared or used by multiple clients, and for either for simplicity or security's sake, we didn't send either the user that requests this report or the user's organization or department within the company or anything about the user. The background job just got the bare minimum of information it needs to generate the HR report. But with only this, we can't really start fixing this issue. We don't even know why it's failing. So yeah, even Sentry errors cannot help you in this case. Not unless you put it on a trace, okay? So when I generated the report, or when I clicked the generate report, I'm actually starting a span. I'm actually starting a trace, which is going to be request annual report generation. That's how it's going to be the name. And luckily, I added the user, the org, and also the client. The client is basically the application that is currently running. There might be multiple applications triggering this background job. So we want to know which application also triggered this background job. So once we do that, we send an API request to the backend, to the API, and in here we just say, okay, create me a new span continuation options and just continue it from the requests. Whichever client sent the requests, if the client added trace headers or started a trace and propagated it to here, to us, then we'll just continue with that trace. Okay, so yeah, we just start a transaction and that's it. Now our backend is continuing the same trace that whichever client started it, and even if we are using something like RabbitMQ, which I am using here, I'm still propagating the trace through the headers. You can see I have a trace parent and a baggage headers. These are built-in functions in every Sentry SDK, and I'm just appending them to the headers of the message. So that's how I can even continue propagating the trace between RabbitMQ messages. But once we do that and redeploy, we're still going to get the error, but this time the error is on a trace. So if we scroll down, we're going to see a trace preview open up here. And if I click on the view full trace, we're going to see the full trace. So here is the full trace, starting from the literal page load when the user opened the website, how the browser loaded the website, and here are all of those request annual report generation. Okay, so let's take a look at them. This one, as we can see, we have the users, user@example.com, it's on the resellers, it's the Acme org, and it's a financial report. So this one is okay. The next one is the operations report. Again, this one is okay. The next one is the HR report, which was breaking, and we can actually see that here. We can see that the queue.task is red, and there's a little fire icon right here that tells us that something is wrong. in this request, but we actually know now that this is the user that triggered the background job. The user belongs to the Acme org, and if we look at the database or our security definitions, we might see that the Acme org does not have access to HR reports because they contain sensitive information, and the Acme org doesn't have permissions to view those information, right? So how do we go about fixing this? Well, yeah, we know that it's the reseller client, and with this we actually have all of the information that we need to reproduce this locally. We are going to boot up the reseller's client. We're going to either use impersonation to log in with the user at example.com, or just create a test account on the Acme org and go and try to generate an HR report. If we see the HR report in the select right here, well, there's your rabbit hole. You can start debugging why we allow Acme org users to generate HR reports where they should not be able to, right? So without initializing that trace on the client side or the client, wherever it might even be a mobile application, without doing that and just relying on the error itself and looking at the stack trace, we wouldn't have known that this is an Acme user, that this is this particular user, and that they try to access or trigger this background job through the reseller's client. So now we know that the fault is in the reseller's client. We can just go ahead and push a fix to the production and look at this error. If it regresses, we're gonna get a new email. So yeah, this is a really quick video to show you how even Sentry errors cannot help you in some of the use cases, especially like in isolated environments like a background job that doesn't have access to all of the information. Simply putting it on a trace and tracing back how that or where that operation originated will get you all of the debugging information that you need. So yeah, I hope you like this video. I'm gonna see you in the next one.